kids.
This instructional video is going to be about the ideal gas law. So actually the ideal gas law is going to be written two different ways. PV equals nRT. Just make sure you guys understand what the different stuff stands for. Pressure, volume. Little n is always going to be the number of moles. R is going to be a constant. It's the universal gas constant. Everybody see it there? And then T is your temperature. Make sure your temperature is in Kelvin. And the reason for that, if you look, do you see on the universal gas constant, you see it's joules per mole times Kelvin. Okay, so you got to make sure you're doing it in times Kelvin. But otherwise, like pretty basic stuff. Actually, I should mention this just to make sure you guys are okay. Pressure times volume is actually joules. Make sure you understand that. It is energy, which is why when we look at the area of our PV graph, it's going to tell you the work. But more on that later. Maybe in a different video. But and I can show that to you if you take a look. We know, hey, pressure is force over area. Force is newtons. Area is meters squared. And then if I go volume is meters cubed. So if I take pressure times volume, I get newtons per meter squared times meters cubed. That goes away. I get a newton meter. A newton meter is a joule, energy, okay? But make sure that you guys can do things like this, okay? Hey, look, you know, a lot of stuff you have to be able to do is this. If I have a process that goes like this, you know, so it goes from point A to point B. Well, what's going to happen to the temperature? Well, if you take a look here, my pressure is constant, my volume is increasing. Well, assuming I have the same number of moles and R is a constant, so that's the same. Well, that means if this is the same and that goes up, well, that has to go up, duh. You know, stuff like that. You know, if I had something where it was like this, okay, so in this case, pressure goes down, volume is the same. Oh, that means my temperature had to go down. If I had something where my temperature is constant, that means this whole side is constant, which means these two have to be inversely related. So if this goes up, this goes up, this goes down, I mean, so you get an inverse graph, you know, that type of thing. So, so hopefully that makes sense. That this version of it, big N is the number of molecules. Well, how do you find that? Well, you use Avogadro's number. So like if I said you have 2 moles, okay, there's Avogadro's number on your formula sheet. You would take 6.02 times 10 to the 23rd, and that would tell you the number of molecules. And then K is Boltzmann's constant, which is, okay, right there, as you can see, the 1.38 times 10 to the minus 23rd. But they're equivalent to one another. You know, if you take the 8.31 times 2, you would get the same number as the 1.38 times 10 to the minus 23rd times 2 times 6.02 times 10 to the 23rd. They're equivalent. Most of the time, if you're talking about an individual molecule, you're dealing with K. Okay, so like, because again, this is the number of molecules. But otherwise, it's the same stuff. So make sure you guys can use the ideal gas law. Bye, kids!